Hello, I'm Andrea Angella, and in this video we are trying to do the examination, paper 1, Theory Fundamentals for AS level computing from May-June 2017. Okay, let's do it. Okay, question 1. We have an hospital that is divided in two areas, areas A and area B. And each area has several wards, and all the ward names are different. So we have a number of nurses that are based in area A, and these nurses always work on the same ward. Each nurse has a unique ID of string data type. Okay, so we have a diagram that is actually a relationship diagram that describes the relationship between a nurse and a ward. So what type of relationship is this? Is the first question. So this is actually called, let me take typewriter. This is called a many-to-one relationship. Well, let me explain. What does it mean? That a number of nurses are based in area A. What it says is that each nurse has a, what is it? Sorry. So these nurses always work on the same word. So a nurse basically works in a single word. So there is only one word where a nurse can work, but in a word there are many nurses. So that's how you should read it. If you read from left to right, you say a nurse work in a word, in one word. While if you read from right to left, you can see that a word can have multiple nurses. So whether are these three small segments close to the nurse box, say the many parts of the relationship, while the end of the line without the other lines basically is the one relationship. You don't really need to mention that, but another possible representation is to basically use one here and n here, just to make it easy to understand. So a word can have n nurses, and a nurse can have one word. Right? So this is a many-to-one relationship. N to one, basically. Okay, so the second question is describing a relational database that contains a word and a nurse tables, and you need to actually complete the design for the nurse table. So you can imagine a table, like actually a table with data, and what you really miss from the nurse table is actually in which word is working. So is what you really need here is the word name. So in the A nurse table, you have the nurse ID, the first name, the family name of the nurse, and also you need to have the word name. And there is only one word name for nurse. Okay. So how this relationship is implemented? Okay, the word name, as you can see, is the primary key of the A word table. So that means that you can only have one. The name is unique, basically, across words. So the word name is a primary key of the A word table, while the word name in the second table, in the A nurse table, is a foreign key that actually links to the primary key in a word. So I would put it something like that. So the word name is a foreign key in the A nurse capital nurse table. So this is a foreign key because it's pointing to a table that is not the table what it actually belongs to. Then and links to the primary key, still called word name. Doesn't need to be. They don't need to be the same, exactly the same name, but it's good practice to use the same name in the A word table. Okay. That's actually how you represent many-to-one relationship using the relational database model. The next question is a different sort of relationship. So in the area B of the hospital, there are a number of wards and a number of nurses. Each area B ward has a specialist, and each area B nurse has a specialist. A nurse can be asked to work in any of the area B wards where the specialism matches with the word specialist. So we have this relationship, B nurse, many-to-many B words. So like this is something that you don't need to put it for the exam, but this is something to actually reflect what this means. So a nurse can be in many words, and a words can have many nurses. So this is definitely a many-to-many relationship. Because a nurse can have multiple specialisms, and so a nurse can possibly work in more than one word. And so that's why it's different than the other one. Okay. Then, similarly to what we did before, how can we model this relationship using the relational model? The way you usually represent many-to-many relationships is using a separate table. So you have two tables that you want to link in a many-to-many relationship, and like bnurse and bword, and you want to actually create a table that's usually called with the name of the two tables combined, bword nurse, that actually put together the primary key of the first table, the primary key of the second table together. So basically, put word name and nurse ID together. And the important thing is that this is actually let's do it. Must be underlined, because this must be the primary key of this table. So it's the combination of word name and nurse ID that makes. Pay attention here. The word name must be capital. So it's a combination of word name and nurse ID that together actually are the primary, represent a unique value in the bword nurse. So this basically say that given this word name, this nurse works in this word name. Okay, that's actually how you represent this relationship. And if you want to do this with a diagram, we've learned that the way to do it is using the three lines in the location where there is the n part of the relationship, and the n part of the relationship is here. Oops. That. So you don't need to put the numbers. I found it quite useful for reading. It's 1 to n and n to 1. So basically, a many-to-many relationship is creating two one-to-many relationships. It's not possible to map directly the many-to-many relationship using the relational model. You always need to have a separate table that actually combine two one-to-many relationships. So, and you can see that for a nurse can only in each row in the bword nurse table can have only one nurse and can have only one word, of course, because it's actually putting together these two values. While a nurse can belongs in multiple nurses, a nurses can belong in multiple words, and a word can belong in multiple nurses, can have multiple nurses. So that's actually how you do it. You combine two one-to-many relationships. Okay, so now we need to write some SQL. Let's see the first question. Write a SQL query to display the nurse ID and family name for all Area B nurses with a specialist of theater. So first of all, we need to see what tables do we need to use. So the family name is inside the nurse table. The nurse ID is inside the nurse table. The specialist is also inside the nurse table. So we only just needed the nurse table to answer this question. So we don't need to do any sort of join or combine different tables. So this is single table query. So what we really want, we want to select what information we want to display. We want to display nurse ID and family name. Okay, from which table are we actually taking this information? From the bnurse table. But what is the filter? We need to only consider the nurses with a specialism of theater. So we need to do a filter using where specialism equal, and then you need to provide the specialism, and that is theater. Okay, and this is actually the query you need to run. Yeah, all the nurse ID and family name from the bnurse table where the specialism is theater. Okay, so then we have a new question. A new question is to do an update statement. So we need to actually update some information in a table. So Fatima Hu is an Area B nurse with a nurse ID of 076. She has recently married and her new family name is Key, I think. So what what are the information that we need to change? Okay, we need to change family name. So we already know that family name belongs in the nurse table, so we need to use the nurse table. And that's it. We only need to actually update that table. So which table we need to update? We need to update the B nurse table. Okay, what do we need to set? We need to set the family name to what value? Key. And where is actually the condition? What is the condition that need to be satisfied? Which rows need to be updated? If we don't put the where clause, you're actually going to update the family name of all the nurses. That's actually wrong. And it's a common mistake when you, for DB professional, to actually unintentionally press enter and run this query across a table and actually unintentionally update all the columns of the table. That's also not what they want. So it's actually quite common. So it's very important to often avoid put a where statement before the update so that you don't actually make the mistake, or use some tool that can help you to avoid when you press enter, we'll actually ask for a confirmation. Are you really sure you want to update all the rows? Or something like that. So where nurse ID equals 076. So because what we want here, we only want to update the row that is related to the nurse with the ID 076, and that's how you do it. Okay. Next. Okay, next we have we finished the relational database questions, and we now move into a question about more generic knowledge about printers, and we need to put in order this sequence of steps to describe how a page is printed using a laser printer. Okay, so you already have the first step, that is a laser beam and a rotating mirror are used to draw an image of the page on the photosensitive drum. Okay, so, and the third step is an electrostatic charge attracts the toner. So then the important way laser printer works is that it's actually create an electrostatic charge on a drum that basically will create a pattern that attracts or not the toner, and based on that, actually the toner will stay on the page or not. So this, the initial step, the most important step you need to do at the beginning, before actually attracting the toners, you need to actually create this electrostatic charge. So if you can see here, the third option, option C, is when the image is converted on the drum into an electrostatic charge. So C is the most sensible answer here. We create the electrostatic charge, okay? And so that then the electrostatic charge attracts the toner. And the toner usually only sticks to the position where the drum has been discharged. The charge paper is rolled against the drum. Okay, so now we have the paper there. And the next step is, okay, now that the toner needs to actually go into the paper. So how does that work? The toner sticks to the position on the page where the to the position where the drum has been discharged. So, and is the actually the B is the next step. So the oppositely charged paper picks up the toner particles from the drum. After picking up the toner, the paper is discharged to stop it clinging to the drum. Okay, so the paper attracts the toner. Okay, so after that, what we need to do is important to actually make the image fully, fully permanent on the paper, and you need to do this with the step A. So you need the paper passed through a fuser, which heats up the paper, need to be heated up, and the toner melts and forms a permanent image on the paper. And the last step is B, that's the electrical charge is removed, and then there is some cleaning up that needs to happen. So this is mostly actually testing your knowledge of the laser printer. So I recommend you to look at page 46 of the course book, that is the Cambridge International AS and A-level computer science course book, that actually describe the whole process about laser printer and also the inkjet printers and the differences between the two. So you actually need to understand and learn what's the sequence of steps. There's a nice diagram that explains the actual components inside a laser print. Okay, so the next question is actually asking what is the most suitable type of printer for actually printing photographs. The inkjet printer is actually the best option usually in this case, even if technology is getting better and better and better, and the gap is getting smaller and smaller. But for high quality printing, for having a better quality, a better color range, high resolution, for photographers, the inkjet printer usually is the one that provides better quality. While despite the laser printer can still print color, but it's mostly used for general purpose images. But specifically for high resolution digital camera photos, inkjet printers was better. Okay, the next question is, okay, the user is considering to purchase a new laptop, and she has read many product reviews and knows that there are different types of internal secondary storage available. And we need to actually list two possibilities. So the two common possibilities for secondary storage are the hard disk drives and the solid state drive disks, SSD, sorry. Oops. Describe one advantage of one of the options. So let's say I pick the option 2. So I'm in this computer that I'm using at the moment, I have an SSD that is a solid state drive. This means that there is no mechanical disk or things that actually move inside this SSD, is all electronic. So this means that the read and write time is extremely fast and is silent. There's nothing moving. So, and also quite robust, because when there is mechanical components inside a device, is higher the risk of that component to break or anything like that. So what are the advantages? Are certainly that is fast, incredibly fast read and write time, and it's silent because there are no mechanical components, right? And is reliable and robust. Say robust. I think you just need to provide one, so it's fine to say just fast read write time is probably the best and what people care about mostly. If you choose the other one, obviously the hard disk drives are usually more are inexpensive, and then can actually have a larger capacity. They can actually store a lot more data. Or SSD, they are quick, but they are also more expensive, and this also means that you usually buy disk of smaller capacity. Right. Let's move on. So next question, we have sampling. Okay, we have a microphone and we capture voices. Before making a recording, the user can select the sampling rate. Okay, so he's asking what is the sampling rate. So the idea is it's fairly simple. So you have the audio signal coming from your microphone. That is definitely an analogic signal. We need to convert this signal into a digital signal. So this means that we need to sample the analogic value at certain intervals, right? So the higher is the frequency of sampling, the higher is the sampling rate. The sampling rate is basically the number of samples you take per seconds or per unit of time that you can decide, right? Usually per seconds you measure. So the sampling rate is the number of samples taken per unit of time. That's usually seconds, right? So if you do 100 samples per second and stuff like that. And so what's how this influence the accuracy of the sound? The reason is that the more frequently you do the sampling, sorry, let me correct this. The more frequently you do the sampling, the more values you actually get. So the more accurate the representation, the digital representation of the sound will be. So the explanation is that higher sampling rate means higher accuracy. Accuracy, right, can't spell. Awesome. Then in terms of bitmaps, what the 10 pixel and screen resolution mean. So if you know an image is just width by height, a certain number of pixel with a width as a width and a height. The pixel is actually the smallest drawable picture element you can actually have. smallest drawable picture element. It's kind of a dot, basically. Okay, this looks correct. Drawable, yeah. And the resolution is basically the number of pixels that there are in total of the image, right? Usually it's the width by height, right? So the resolution is the number of pixels which can be shown on the screen. For example, HD resolution 1920 by 768 pixel. That's the resolution, right? So the total number of pixels is the resolution, and the pixel is the smallest drawable picture element, right? So a picture has been drawn and is saved as a monochrome bitmap image. So state how many pixels are stored in 1 byte. Okay, so because it's a monochrome, this means only black and white, you just need a single bit in order to store the information of the color. Because a byte contains 8 bits, the answer is 8. 1 byte contains 8 bits, so this means that can represent 8 pixels. Then we have a second picture that is 2,480 pixels wide and 512 pixels high, and it's saved as a 256 color image. All right, so the total number of pixels on the image, total number of pixels, that's basically the resolution, is 2048 by 512, right? This is basically the number of pixels, total number of pixels. Right. So how many bytes do we need, right? So a color, because we want to represent 256 colors, that means that we need 8 bits in order to represent this. So we need 1 byte to represent a color, right? So the total amount of bytes needed is 2014 by 412 by 1, right? And you don't need to calculate that, but let's calculate that. No, we don't really need to do that. Let's not do that. But attention, the question asks the number of kilobytes. So we need to divide this number by the number of bytes in a kilobyte, that is 124. This means that this will be 2 by 512 equals 124 kilobytes. Right? So 1 kilobyte equals 1024. Right? This is the answer. But the actual bitmap file size is larger than the value we calculated. So we need to state another data item that the bitmap file stores in addition to the pixel data. Usually, the beginning of the image, there is an image header that contains various information about the image, like the author, the image resolution, the color depth, and so on and so on. Or the coordinates where actually the image has been taken and so on. You can actually store a lot of information in there, but one of the common one is actually the resolution of the image and the color depth, for example. So the bitmap header that contains the image resolution and the color depth, for example, but could actually contains a lot of other stuff. Okay, so the next topic is actually the assembler language. So we have a description of some instruction: immediate addressing, direct addressing, indirect addressing, indexed addressing, and immediate addressing. So we need to understand if the various questions are actually there to test that you can understand these different types of addressing. So let's see the question and then understand the various addressing. This is actually a set of instructions that can run in a computer. Okay, so the first things we need to do is we need to show the content of the accumulator register after each instruction is executed. So a register, like the accumulator, is a location in memory that usually contains data that can be used as part of the operations, right? Usually the results of operation goes in there, or the values of some operands that need to be used. So here we have LDM 500. So LDM is the first instruction here, and 500 is a number. What it does, the instruction, say that it loads the denary number n to the accumulator. So the answer to this question is fairly simple, because we actually say exactly the denary value that we want to load in the accumulator. So the answer is 500. So we are saying to the computer, please load 500 into the accumulator, right? And that's it. This is actually called immediate addressing. The second question is LDD, that is a direct addressing. While the parameter that you pass 500 is not the actual number that needs to be saved in the accumulator, but it's the location at a given address to the accumulator. So it's the location of a memory, is a memory location. So if you look at 500 in memory, you can see that the memory consists of an address and a value. So each location of the memory is addressed using a particular address. And as you can see here, 500 is the address, and the location in memory is, oops, you can see. So 500, this one is the address, and this is actually the value, 496. That is the answer that we are looking for, 496. So the LDD means direct addressing. That means, okay, go to the location in memory at the address 500 that you provide, take the value in the memory location and load it into the accumulator, okay? So that's why it's called direct addressing, because it's direct. Go directly to that location in memory and load the value, okay? The next instruction, LDX, instead is the indexed addressing. That instead of going to the address that you provide, 500, you need to go to the address plus the content of the index registry. And in our case, the index registry is the value of the index registry is 3, as you can see here. So 3 is the value of the index registry, IX equals 3. So we need to go to 500 plus 3. That is 503. Right? So this is the actual address that we need to look into, and then the value is 502 that we can actually copy here, and this is actually the result, 502. Okay, so this is called indexed addressing. It's very useful when you want to actually access the values for sequence of numbers that are represented as arrays in memory. So let's say you have an array of 5 numbers that are all consecutively positioned in the memory, and you can use the index address, the index register, to actually get the number in position X of the array, starting from a particular base address that you provide. So index addressing is very useful and is usually used by the compiler to generate code that access arrays. Like you've probably seen in Python stuff like P3, like that. When you do something like that, you basically tell this code will be translated using an indexed addressing, where P is the location of in memory as represented as actually a label, kind of, and 3 is actually the index, the value that will be set to the index registry, right? So that's actually a very useful operation. And the last one, LDI, is indirect addressing. That is quite interesting. So this is more about it's more the way to do a pointer indirection. So the idea is that you take 500, you look at the value inside 500, but you don't actually take that value. You consider that value, 496, as another address. And so that you look up where the location in memory, 496.2, that is this one, and then you take 86. And that's why it's called indirect, because you go into memory and then you go in another location in memory. So it's indirect. You don't go directly to the location in memory that you want, but you you basically do two bounces, right? You first go into memory, then you look at the value into memory, you interpret that as an address, and then you go to the final location in memory with the value that you want to load. And this is basically commonly used when you want to reference a pointer. So basically, the location in memory at the location 500 is actually a pointer. And you know that pointer values are basically variable that contains addresses to memory locations. So the LDI, the indirect addressing, is a way to do the reference pointers in assembler. Okay, so this is actually how you do addressing using this processor. Okay, the next set of questions. Each machine code instruction is encoded as a 16 bits, and write the machine code for the following instruction. So this basically is a way to ask you how to encode the instruction. You know that at the end of the day, all the instructions, all the values need to be converted into binary. So the assembler doesn't exist. It's just a easy representation of basically an instruction set of a processor. So, and that's why we have in this table, we say the opcode is actually the binary representation of the operation that you want to do. So the opcode in binary and followed by the binary representation of the operand. That could be an address, it could be a specific value. So the first question is asking LDM. So the first 8 bits are actually the opcode. So what is the opcode for LDM is 1. So let's put it there. So it's 1, 0, 0, 0, 0, 0, 0, 0, 1. And that's the opcode for LDM. And what's the opcode for, so what's the actual value that you, for 17? So you just need to convert 17 into binary. And you can do that easily like that. You know that, sorry, this is 1. You know that this is actually value 16 and this is value 1. And so the sum of these two bits set 1 will be 17. That's how you can convert it. Right. Then LDX, what's the opcode for LDX? LDX opcode is this one, 0000110. So let's copy that. 0, 0, 0, 0, 0, 1, 1, 0. There we go. And then what is 97 here? So here again, I need to convert this into number. So 7 is odd, there will be 1 0 here. And I know that 96 is 32 plus 64. So I know that this is 64, this is 32, and these are zeros. If you don't want to do this on your head, you can just do the classic way of converting numbers into binaries by dividing by 2 and taking the rest. The next question is using an 8-bit operand, state the maximum number of memory location in denary that can be directly addressed. So this is basically asking how many numbers you can actually represent using an 8-bit representation. And that's actually quite simple. It's 2 to 8. That is basically 256. You can do 256 memory locations. The next question is write the hexadecimal representation for this instruction. So the hexadecimal approach consists of taking bits 4 by 4. So let's take this 4 first, and then take this 4, and then convert this into a single alphanumeric letter. So up till 9, you can use 0, 0, 1, 2, 3, 4, 5, 6, 7, 9, and then 10 is represented as A, 11 is represented as B, and so on, up until 1, 1, 1, 1, that is represented as F. So in here, there are 4 zeros, so the first value is certainly 0. So this is 0. This value is, you can see 1, 1, 1 is actually 7. Then we can see the other bytes, this 4 here, and then this 4 here. Let's have a look at what are numbers. So here you can see 1100. What's number is that? You can see that is 8, 9, 10, 11, 12. So this is equivalent to 12, and this is equivalent to 2. So 2 maps directly to 2. But 12 can be represented in a single digit. So you know that 10 is A, 11 is B, and 12 is C. right? And that's basically what you need to do. So the numbers is 07C2 in hexadecimal. So basically what we have in terms of mapping is 1010 is A, and 1011 is B in hexadecimal, and 1100 is C, and 1101 is D, and 1110 is E, and 1111 is F. Okay, that's actually the table. All the things below are actually the number, the digit. Okay, now you need to do the inverse operation. Given the hexadecimal representation, you need to actually convert it into, I don't know, actually you need to convert in the instruction. Okay, so 05 is the opcode. So 05 is the opcode. So it's 0101. What is the opcode 0101 is, you can find it in the table. Oh, it's actually LDI. So you know that the assembly instruction is LDI, and 3F need to be converted in the denary equivalent. That is, okay, so let's try to use it here. So 3 and F. So I know that 3 is in binary is 0011, and F is, we have a table here, is 1111. Okay, so I need to convert this into binary. So this basically is equivalent to 1 plus 2 plus 4 plus 8 plus 16 plus 32. That equals, oops, that equals 63. Yeah. So the operation is LDI 63. Okay. The next question is about parity. Okay. A computer receives data from a remote data logger. Each data block is a group of 8 bytes, and a block is made up of 7 data bytes and a parity byte. Right. So the last column here is made of parity bytes, and the last row here, this one, is the parity byte. Each data byte has a parity bit using an odd parity. Okay, this means that we need to make sure that the number of ones is odd for each row and for each column. And the parity byte also uses odd parity, so the same for the other. The following table shows a data block before transmission. Okay, we need to describe how data logger calculates the parity bit for each of the bytes in the data block. So this is fairly simple. You need to look at, for example, for the first column, you need to look at all the values in the first 7 bits, right? Count the number of ones. If the number of ones, count the number of ones, and then set the bits here, the bit, the 8th bit, in a way that the total number of ones is odd. For example, you can see that the total number of ones in the first 7 bits is 4 in these cases, so this is definitely even, so it's not odd. We need to set the 8th bit to 1, so that the total number of bits is basically odd, right? So let's put this into Word. So I would say count the number of ones for the first 7 bits. Set bit in position 0 to 0 or 1 to make the overall count of the overall number of ones, not number. Okay? That's actually how parity works. State the 2 missing parity bits labeled A and B. Okay, let's have a look. The first A, so we need to look at this line here. How many bits there are? 1, 2, 3, 4 bits. Okay. So A need to be set to 1 so that we can make the number of bits 5, that is odd. And then the other column we need to look at is, let's see if I can remove that, is this one. So how many ones there are? 4 ones. Again, is even. We need to set b to 1 in order to make the total number of bytes to 5, so that we have a odd number. So both A and B need to be set to 1 to have an odd number of bits. So let me put it there to remind me. So this is going to be 1 and this is going to be 1. Okay. 1. 1. First idea, so it's a bit more readable. Okay. There we go. Okay, So the next question is describe how the computer uses the parity byte to perform a further check on the received data byte. So the parity byte is this one. Okay, so the way to do this is the parity bytes is calculated in the exact same way as the other one. So instead of checking the number of 7 bits in a row, you check it in the column, right? So you check the number of ones in this column, and then make sure that the parity bit is set in a way that the total number of ones in the row, in the column, is odd. In this first case, there is 1, 1, 1, 1, 1. There are 5 ones, and the parity bit is set to 0, so that actually looks correct. So the way it does that is for each column calculate the parity bit and then compare it with the corresponding received parity bit, right? So if they actually not the same, it means there's been a mistake, and then actually can be localized somehow. So we'll see that in the next question. So let's put into Word. So basically, for each column, calculate the parity bit and compare it with the corresponding received parity bit. If they are different, an error occurred, and the error can be localized. And actually, the next question is all about localizing the errors. So let's see. A second data block is received as shown in the following table. There are errors in this data block. So identify and then circle 2 bits in the table which must be changed to remove the errors. Okay, so we need to check which values are actually correct. Okay, let's have a look. The first row, there are 3 bits to 1, and the parity bit is set to 0. The total number of bits is 3. It's correct. It's odd. The second has 1 the number of ones is odd. That's correct. The third row, the number of ones is 4. That is even. So this is wrong. So this row is. Oh, sorry. This row, the third row, is wrong. We know there is an error in there. Then move on. There are 5 ones in the next row, 3 ones. Then there are 2 ones. Oops, this one is even, so this is definitely not correct. And the last one, there is only one number. There's only one. So the odd is fine. So we can do the same process for the columns, and we can see, the first column there are 3 ones, correct. The second column there are 2 ones and no 3 ones. That's correct. The third column, there are 1, 2, 3, 4, 4. That's actually even. That's incorrect. So we have an error here. Then we have 3. Then we have 2. Oops, this is even. So this is an error. 1, 1, 1. This is 3. That's correct. 1, 3 is 1 is correct. 1, 1, 1. 3 is odd. That's fine. So we know that the third row, the row number 3 and row number 6 are incorrect, and the column 3 and column 5 are incorrect. So now we need to make a change in order to fix this, right? So the way to do it, like for example, if I could make this one, let's say I could make this one here 0, right? And I could make this one 1. So basically I need to flip the bits. So let me just circle the one I want to change instead of actually writing the number. So I can change this one and this one, for example. And if you do that, like this bit becomes 0 and this bit becomes 1, you know that this is going to work. So the key thing here is making sure that you only change 1 bit in a row and 1 bit in a column, but never 2 bits in a row and never 2 bits in a column. Because if you actually change the values of 2 bits, you don't actually change the overall number of odds and if the odds and numbers. So it's very important to actually change this one and this one, or this one and this one. Okay, you have 2 options, right? You could do that, or you could do the other. So this is one possible option, and the other one is actually doing that and that. But never change the values, 2 values in the same row on the same column. Otherwise, you do not actually localize the error. So you don't really know exactly where the error is. So, but you need to change those 2 bits in order to fix the error. Okay, so explain how you arrive at the answer. So how can we put this into words? Analyze each row and identify rows with the correct parity, and do the same for columns, and then identify the intersections. Okay, good. Next. Okay, question about operating systems. You need to actually draw a line to link each operating system management task to the appropriate user action. So, main memory management and is related to the user close the spreadsheet program. So when you close a program, you basically need to make sure that the memory used by that program is actually freed so that other processes can use this memory. So the main memory management is perfect in this situation. So for the first action, the user moves the mouse on the desktop. You can see there is no I/O, is no secondary storage, it's actually human computer interface management. So that is all about the UI, how the user perceives the operating system, so the mouse, the way it's interacting with the computer. When the user select the save command to save the spreadsheet file, so actually you need to save this information on a secondary storage system, like an HDD or SSDT drive. So the secondary storage management is what's responsible for actually saving files to disk, for example. And the last action, that's actually printing a command, means that the operating system needs to send the bytes to the printer in order to print the document. So this actually is the responsibility of the input and output management system. Its whole responsibility is about communicating with external devices. And this is actually how you would actually do the mapping. So now we need to say which software can provide a solution of a particular problem. So the first problem is we have an hard disk that stores a large number of video files, and the computer frequently runs out of storage space. So, oh gosh, we have a lot of files, a lot of big files. Videos are usually big, and we run out of space. How can we solve this problem? We need to compress those files. If we actually compress them, we will be able to save more files. So the solution here is to use file compression software. All right. Then the second problem is the user is unable to find an important document. He thinks this was deleted in error some weeks ago. This must not happen again. So how can you prevent yourself from actually losing data? One of the most important and common techniques is to regularly do backups of your software. So create regular copy of your software or your data frequently enough so that if you maybe lose it, you will be able to restore them from a backup. And in order to restore this information, you usually use a backup software, restore or actually save the data. The other problem is the operating system reports bad sector errors. Okay, so a sector is a location on a disk, right? This means that something goes wrong in the secondary storage. So what we can do to do that, we can use some tool that helps to try to analyze the disk and repair the problem. So usually these are called like disk repair tools. Then the next problem is there has been some unexplained images and advertisement appearing on the screen, and the user suspects it is malware. So this is very classic. Could be spamming, or could actually a virus. So the best way to prevent this problem and solve this problem is to use an antivirus software. Excellent. Then design a web-based application can require the use of client-side scripting. So describe what is meant by client-side scripting. All right, so this basically is code that is part of a page that runs on a browser, or that is the client. So that's usually written in JavaScript. So the requested web page, contains code that is executed by the browser. The browser is the client, and the server is actually the server that hosts the web page. So then we need to see how a user requests a web page using the URL and insert that in the address bar of the browser, and then the requested page contains a client-side script. We need to see the steps leading to the display of the web page on the computer screen. All right, so the idea is that the browser takes the URL and try to find the domain name from the URL, extract the domain name from the URL, and send this to the DNS server. So basically, that's a DNS request, to resolve the name, because computers can only communicate using IP addresses on a network. So the DNS server returns with an IP address, and then the browser do a request to the web server using the IP address that they received, and then the web server returns the page that is actually interpreted and displayed to the screen. So the browser determines the domain name from the URL and send a DNS request to resolve it. Right? Resolve a domain name and get an IP address. Then the browser send a request to the web server using the IP address. So the web server returns the page that is interpreted, excuse me, and displayed screen. Right? That's actually how it works. And the last part of the paper, we have some JavaScript code, and we need to actually answer some questions. Okay, let's have a look. So this is an HTML page. As you can see, is actually wrapped inside the HTML tag. There is a header, and that's where that usually contains the JavaScript code that can run on the page. And then there is a form that contains various input fields that the user can actually use to type. So you can see the page consists of two text boxes, one to insert the product code and one to insert the number. And then you can press the button and then show some information on an alert, right? So this code is actually running on the browser. So and you can see from the code here that you have a input type button, and then you say on mouse down equals the name of a function, and this name of a function points to a function here that is in JavaScript, and the function actually does some logic, and we can actually try to understand that based on the question. So let's have a look. The developer has used 3 variables in the JavaScript code, and state identifier used. So the JavaScript code is actually this one. So this is actually the function that contains the JavaScript code. Oops, that's not what I want to do. Can I do without filler? Fair enough. So this is actually the function. What variables? So the way to define variables in JavaScript, you do var, name of the variable equals a value. So you can see that we are creating message1, message2, and x as variables. So message1 contains the error or the refused, the message2 contains product code OK, and the x contains the result of this expression. That, as you can see, that this one is trying to get the form called form1. As you can see, this form1 here match to the name of the form here, and the txt product code match to the name of this input field, right? So it's trying to get the value that the user enter in the product code here, right? So x will be that. So to answer this question, we just need to put message1, message2, and x. Message1, message2, and x. The button as an event also identified is on mouse down. So when the submit button is clicked, some code is executed. So state the line number that contains this code. As I said before, the function starts on the line 6 and end on the line 19. So it's from 6 to 19. The JavaScript code uses a selection statement, so basically an if statement. State the line number that contains the condition. So what is the condition here? You can see an if statement. So 11 is the location where the if statement is added. And what is the purpose of this validation? So let's have a look at the code. So it's checking if x is an empty string, do alert message1, and message1 is error. So if x, that actually is the value from the product code, if the product code value inserted by the user is empty, shows an error message. So it's actually making sure that the user actually enter a product code. So that's actually the purpose of that. So check that the product code is not empty, or maybe it has been entered by the user. So it's not empty. It's not empty, it's fine. Or it's not an empty string. Right. So now we can say name, describe 2 of other types of validation check that could be appropriate for this data capture from. So what we could do is, you can see that we haven't checked the text number, so we haven't checked the number here. You could actually put -3, or you could put ABC in the number; it will still work. So that's certainly something I would just do. So let's say the type of validation check is called format check. So you are checking that the format of a particular value is correct, and I would check that that TXT number contains an integer number. For example, does not contains letters, right? And the other possible way is that the product code might just not be, I don't know what's the format of the product code. Maybe product codes are only made of 9 digits or anything like that. So I would still do another format check to make sure that the actual format of the product code is correct. For example, a 5 digits number, whatever, right? It depends by your system. And this is actually the end of the test. So I hope you understand the various questions and answers of the test. If you have any question, feel free to ask me a question on Slack or send me an email on angela.andrea@gmail.com. And thank you very much for watching.